Hello, Algebra Honors. We are looking at the Algebra Honors Unit 8 study guide. So your Unit 8 assessment is actually going to be open notes, but we're giving you a study guide that you should treat this like it's not going to be open notes. Usually that's easier, and then you just have an extra backup of notes that you can use to help you solve these problems. Also, you'll be allowed to use Desmos in addition to your notes, but you're going to have to show your work. So make sure that when you do these problems, you know how to show your work, and you'll be ready for your test. All right, problem 1, this actually says directions, but I hole punched so you can't see the D. Problem 1, we're going to graph this function and identify the following steps. Okay, so we have all the way to f, so we're going to start by looking at our equation, y equals x squared plus 2x plus 1. I know just looking at it that my leading coefficient is positive, so it should be a parabola that opens up. I know it's a parabola because we have something squared. The axis of symmetry, the way we solve that is it's going to be a Vox line, a vertical line, so x equals some number, but I can find my number because I know x equals negative b over 2a. Okay, and so I see a is 1, b is 2, c is 1, so I'm going to say negative b, negative 2 over 2 times a, and my a is 1, and so I have negative 2 over 2, which is negative 1. I know that then x equals negative 1 is the equation of the line that is my axis of symmetry. So I know that I have an axis of symmetry right here at x equals negative 1. Okay, now the coordinates of the vertex. I know the x part already. Remember, it's always an ordered pair. So I know my x part of my ordered pair is negative 1, and I need to find the y part. I'm going to plug in x equals negative 1. So y equals negative 1 squared plus 2 times negative 1 plus 1. So it equals 1. 2 times negative 1 is negative 2, so 1 minus 2 plus 1. 1 minus 2 is negative 1, and negative 1 plus 1 is 0. Okay, so if my x input is negative 1, my output y is 0, so that is my vertex at negative 1, 0, right there. Remember, we already know that we have a parabola that's going to open up, and that is going to be my minimum, because that's what the vertex is. It's either the minimum or the maximum. Okay, so my domain, what are all the x's that I could possibly have? Well, I'm going to look at my graph to figure that out. So to find a graph, we would like to do an xy table of some sort. Xy table. Okay, and so I'm going to pick an x or 2 that I'm willing to use. I love x is 0. If x is 0, y is 1. Right, so 0, 1. That gives me 2 pieces of information. It gives me the y-intercept also, right? And it gives me an ordered pair somewhere for my parabola. You knew that we were going to cross the y-axis at 1 anyway, because in standard form, that's what that c value tells you. Right, remember, this is my axis of symmetry right here. So I know if I have a point whomp, 1 to the right of the axis of symmetry, I must have a point whomp, 1 to the left. Okay, and so I might choose another x value. I'm going to say, what if x is 1? If x is 1, then I have 1 squared is 1. 1 plus 2 is 3, and 3 plus 1 is 4. Okay, if I have 1, 2, 3, 4. Look at this. This is whomp, whomp. It's 2 to the right of the axis of symmetry, so I'm going to go whomp, whomp, 2 to the left. Okay, and so I can kind of see that's what my parabola is going to look like. Kind of sketch that out. Okay, there's my parabola. That's a little better. It's not super pointy. So my domain then is all of my x values. So I look here, and I can see that I am continuing on forever toward negative infinity and positive infinity in the x directions, right? There are no restrictions on what my x value can be. So I'm going to say x is all real numbers, but in interval notation, I have to say we go from negative infinity all the way to positive infinity. Use parentheses for infinity since we can't actually put our finger on a spot and say this is definitely the infinity space. Okay, our range, I'm thinking about my y values. There is a minimum y value. My smallest y that I can possibly have is right here at 0. There's nothing lower than that. So it can be 0, so I use square brackets, and it can go up all the way to positive infinity. It's going up forever. My zeros or my roots, that's where I'm crossing the x-axis, and I can see that I'm crossing the x-axis in one spot at x equals -1. X equals -1. If you can, oops, I'm sorry, x equals -1. If you can see it on your graph, great, but you can also plug this in up here because we know the 0 means that it's when y equals 0 or when your output equals 0. So if we had to solve it, we would say 0 equals x squared plus 2x plus 1. I notice that this is a perfect square trinomial. So I know that this means that 0 equals x plus 1 squared. And if I take the square root of each side, I know 0 equals x plus 1, which means that x equals -1 because I subtract 1 from each side. Okay, so I can find the zeros several different ways. I can find it by looking on the graph. I can find it by setting the whole thing equal to 0. Okay, and we could have factored this using the x puzzle as well. There are a couple ways to do that. My y-intercept, you know that's what happens when x is 0. And so, first of all, I can see this is my y-intercept, but also if x is 0, I get 0 plus 1. And so I have, if x is 0, y is 1. So my y-intercept is going to be the ordered pair 0, 1. All right, so we've answered A through F, and we've graphed our parabola roughly on there. And so now we're going to move on to questions 2 and 3. So questions 2 and 3, it says use the discriminant to find the number of real number solutions for each equation. Show your work. So we remember the discriminant is b squared minus 4ac. That is the discriminant. So I'm going to look at each one of these equations, make sure that I'm in standard form and equal to 0, and then I'm going to define a and b and c. So here a is -10, b is -4, and c is -2. I'm just going to plug that stuff in. Okay, b squared, -4 squared, minus 4 times a times c. Okay, so I have 16, -4 times -10 is positive, 40 minus, times -2 is -80, so 16 minus 80 equals -64, -64. If my discriminant is negative, if it's less than 0, I have no solutions. All right, I'm going to find the discriminant over here. I'm going to set everything equal to 0. So I have 2x squared minus 9x plus 10 equals 0. So my a is 2, b is -9, and c is 10. So b squared minus 4ac, that's what we're doing, right? B squared, -9 squared minus 4 times a times c. I end up with 81 minus 80 equals 1. My discriminant value is 1. That's a positive number. So you don't care what the number is. That's a positive number. If I have a positive number, it means I have 2 solutions. All right. Incidentally, on your SOL, you're not going to be required to use specific methods to solve these problems. And so in general, however you want to solve these problems is just fine. If we give you a specific suggestion on how you can solve, it's probably the more efficient way to solve. Okay, just so you know. All right, solve the equations using square roots. That means I'm going to get x all by itself. It means I have usually no bx term, no middle term. So I'm going to rearrange this so that I get x squared all by itself, so that then I can get x all by itself. Subtract 27 from each side. -2x squared equals -80. Divide each side by -2. I have x squared equals 40. And now I'm going to take the square root of each side. Square root undoes square. So I have x equals positive or negative square root of 40. But I know that I can simplify that radical. You always want to do that. And so I have x equals positive or negative 2 roots of 10. This is the same as the square root of 4 times the square root of 10, so 2 roots of 10. Okay, it didn't specify that I needed to do decimal form, so I'm going to leave that in simplest radical form. Over here, 1/2 x squared plus 65 equals 81. I'm going to subtract 65 from each side, and I get 1/2 x squared equals 16. So let's double each side, right? Multiply each side by 2 to get rid of that 1/2. So I have x squared equals 32. I will now take the square root of each side. Square root undoes square. So I know x equals plus or minus the square root of 32. Well, we know that 32 is 16 times 2. We just did that math to get to 32. So I'm actually going to say I have a perfect square. X equals plus or minus 4 times the square root of 2. Okay. So 6 through 8, we're going to use factoring. Okay, and again, you really can use many different methods. We're going to use factoring here. Factoring, if my leading coefficient is 1, I know that once I do my x puzzle, I can just drop those magic numbers I find into my two binomials. Okay, so here we have AC, 1 times 14. What two numbers multiply to give me 14, but add up to give me -9? That should be -7 and -2. -7 times -2 is positive 14. -7 minus 2 is -9. And so those are my magic numbers, and I'm just going to plunk those in. I have x minus 7 times x minus 2 equals 0. If you see already that your x values have to be 7 and 2, you can write that down. This would be enough work. Or you can say that you know, because of the zero product rule, x minus 7 has to equal 0, or x minus 2 equals 0. So we're going to say x minus 7 equals 0, or x minus 2 equals 0. So I'm going to add 7 to each side. X equals 7, or x equals 2. Either one of those is true. So I can say x equals 2 comma 7 if I want to put it in numerical order and write it that way. All right, up here I'm going to use factoring, and so of course I want to make sure everything's equal to 0 and in standard form. And I have, you know what, I'm going to take out my greatest common factor first. So I'm going to divide everything by -64. That leaves me with x squared minus x equals 0. You're allowed to manipulate this. You can take out your big daddy factor first. Now I see that I need a equals 1, right? B equals -1, and c must equal 0 because we don't even have a constant term. So I need two numbers that multiply to give me 0, but add to give me -1. That's weirdness. That's just not even a true thing. We can't do that. We're going to say this is prime. Even if I hadn't divided everything by -64, if I needed two numbers that I still would have multiplied to get 0 and add together to get -1, it's just weirdness. It just doesn't work. Okay, prime right there. Can't factor that guy. -3x plus 7x equals -10. We're going to add 10 to each side. We want to set that equal to 0. So I have -3x squared plus 7x plus 10 equals 0. So I'm going to factor, but this time when I use my x puzzle to factor, I know I'm going to have to actually do a little extra work since my leading coefficient is not 1. So I need AC, -3 times 10 is -30. Two numbers that multiply to give me -30, but add to give me 7, and that's going to be positive 10 and -3. 10 times -3 is -30, 10 minus 3 is 7. So I'm going to rewrite this. I'm going to rewrite 7x using my magic numbers. So I know I have -3x squared plus 10x minus 3x plus 10 equals 0. And now I'm going to factor from the first two, and I'm going to factor from the second two. I can pull out an x, and I'm left with -3x plus 10. And then I have -3x plus 10. I can only just pull out a 1. -3x plus 10. This all equals 0. So I know that x plus 1 times negative 3x plus 10 equals 0. This means x plus 1 equals 0 or negative 3x plus 10 equals 0. So I know x equals negative 1, or I know negative 3x plus 10 equals 0 is going to tell me negative 3x equals negative 10, and so x equals 10/3. Whoops, I'm on my 10/3. I'm on my, what do you call, hole punch hole, okay? So my answers are x equals negative 1 or positive 10/3. Okay. The last two problems asked you to solve using the quadratic formula. You are using Desmos, so definitely check your work. But since we have to show work, we're going to write out what we're doing, and we get to leave our answers in radical form. Okay, so I'm going to set everything equal to 0 and make sure I'm in standard form. So I will have 8x squared minus 8x minus 13 equals 0. Make sure you believe me on that. X equals negative b, negative of negative 8, plus or minus the square root of b squared, minus 4 times a times c, all over 2 times a. Okay, so I have 8 plus or minus the square root of 64 plus 416 all over 16. So I have 8 plus or minus the square root of 480 all over 16. Whoops, there you go, all over 16. And I know 48 is divisible by 16. So this is 8 plus or minus 4 times the square root of 30 all over 16. I'm nearly done, but look at this. I have 2 terms in the top and 1 term in the bottom, and everything is divisible by 4. So I'm going to say 2 plus or minus the square root of 30 all over 4. And that's my answer here. And then finally over here, I know a equals negative 1, b equals 15. Shoot, that's just not even true. I have to put that in standard form, right? Hold on. Like magic, we will pretend I didn't go straight there. Okay, let's put this so that it's standard form. So I have negative x squared. I'm going to add 3x to each side, so I have plus 18x and minus 73 equals 0. So double check and make sure you agree with me. Negative x squared plus 18x minus 73 equals 0. So a now equals negative 1, b is 18, c is negative 73. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. All right, now we're just doing a whole bunch of math. So I know that's negative 18 plus or minus the square root of, this works out to be 324 minus 292 all over negative 2. And so that works out to be negative 18 plus or minus the square root of 32 all over negative 2. And I know that is negative 18 plus or minus, I know that's 16 times 2, right? So 4 roots of 2 all over negative 2. And now I'm just going to simplify. Again, I have 2 terms in the top that are divisible by negative 2. Let's get rid of that negative. And so we're going to say negative 18 divided by negative 2 is 9 plus or minus. 4 divided by negative 2 is negative 2, but if I'm adding negative 2 or subtracting negative 2, it's the same as plus or minus 2. I hope that doesn't confuse anybody. And that's my answer. I'm just going to pause and say that again. I did negative 18 divided by negative 2 is positive 9. So I have positive 9 plus or minus 4 divided by negative 2 is negative 2. So it's plus or minus negative 2 roots of 2 but that's redundant, right? Because plus -2 is the same as -2. Minus -2 is the same as +2, so those are our answers. Anyway, thanks for watching, and I hope that helps.